Okay, so here we're given a problem. The problem is stated as a 75 milliliter solution of hydrochloric acid with an unknown concentration is titrated to the equivalence point with 27.3 milliliters of 0.157 molar calcium hydroxide. What is the concentration of hydrochloric acid in the original solution? So we go ahead and write out the equation. That's the first step. And doing so, we have to find the outputs, and we can do so using charges, and it's necessary in order to balance this equation because it will be useful later on because we need the stoichiometry. So here I went ahead and read out the given, and just to put this in words, it is, we have the volume of hydrochloric acid, which is 75 milliliters, we have the volume of calcium hydroxide, which is 27.3 milliliters, and we have the concentration of calcium hydroxide, which is 0.157 molar. And we're looking for the molarity of the hydrochloric acid. So this is the illustration of the problem, which is just calcium hydroxide being added to the hydrochloric acid, or the hydrochloric acid being titrated with calcium hydroxide. So then we go on to the real problem, the real steps here. The first major thing to just avoid mistakes is to convert milliliters to liters. And we do so because we know 1 liter is equal to 1,000 milliliters, so we just divide the numbers given by 1,000 and give us the decimal as shown. So then we have to find the moles of calcium hydroxide, which we can do so knowing the equation that concentration times volume is equal to moles. So we plug in the concentration that we're given with the volume converted to liters, and we get the output of moles, long decimal there. So then we have to convert the moles of calcium hydroxide to hydrochloric acid. And doing so, we have to use the stoichiometry of the balance equation, as shown up here. We have, for every 1 mole of calcium hydroxide, we have 2 moles of hydrochloric acid. So we go back down to the problem, and we use the conversion chart, in which we use the moles we're given, versus 1 mole of calcium hydroxide in that, and there's 2 moles of hydrochloric acid. So we go ahead and basically we're just multiplying that number by 2. We get the output of the decimal there as shown. And then the last step is to convert hydrochloric acid moles to molarity. We do so by using the same equation as we used earlier, except we have to reverse it this time. We have to divide the moles by volume in order to get concentration, just shown by then. And then we go ahead and plug that in, and we get the moles of hydrochloric acid divided by the volume of hydrochloric acid, and that gives us that molarity there. And so basically your answer should be 0.11 molar hydrochloric acid. So that's totally the thing. Pretty quick run through. And then we're going to highlight some mistakes that people often make in the equation, common mistakes. People will use the incorrect equation instead of the multiple steps that we had to do. They'll use this one, thinking that it will be a simple fix, but it's not. And then people obviously forget to convert milliliters to liters. It's a simple mistake, just something you can quickly run over and miss. And then also people forget to balance the equation or balance it incorrectly and do not use the stoichiometry. So just make sure to avoid those mistakes in the future, and that's all.